container. Why?
We can run numerous containers as we require, and we don't have to pay initial cost as we require more initial cost in VM and the server.
Yeah. So you just require, you are using an existing OS, then you will take it and you will run. Okay. So you have here, one minute, let me take it here. So you have operating system. So on the operating system, you will be sharing this direct container. Here for VM, what you need to have? You need to have a complete OS. Okay, complete OS, and then you will be running the application here. Okay, here the OS is shared here. Okay, so here you are running the OS. Okay, and then on top of it you are running the application. So here in physical server, so you are directly running it. Okay, but it requires power, cooling, and real estate. All it required. So, so now your by default your option is to pick the container. Okay. So now I will take one more here option. Okay, I am running the app here, app one. Okay, on the container. This is a container here. Okay. So I am running one more container and one more container here. Container A, container B, and container C. So let's say these all are being run under a virtual machine, one VM. Okay. So now I am running container D and container E. Okay. This is on other VM. Okay. This is VM1 and this is VM2. Okay. So now this I am running it on one physical server, or I will call this as node. Okay. Or let's say this is a laptop here. Okay. So this you are clear?
Yes, yes, sir.
Okay. So now I will tell you. Okay. This is app container Nginx one. This is SQL and this is PHP. Okay. So whenever a user comes here, this is connected like this. Okay. This it is running. Okay. So now if I want to talk to this container, okay, let me change the color here. Okay. So I want to talk to this container D. So how I will talk? Okay. So within these containers, you can communicate each other. With each other, you can communicate. Okay, this is on the same VM. Okay, let me draw this boundary. Okay, these are the same boundary. Now you can connect it. Okay. So let's say you have done some mechanism to do some uh, here some intelligent people what they have done, they have done a bridging here. So let me put it. So I have a network here. This is a Wi-Fi network. Okay. This is a Wi-Fi network. They have a bridged adapter. Okay. So So they have created VM here, bridged adapter, and then NAT adapter, something like that they have created in the VM here. Okay. So bridged adapter, it is going like this, and then this is also connected. Okay. So through this we will communicate like that, they will tell. Okay. So we will go here and we will communicate. Okay, this also fine. Okay, I will agree. So I have one more here. So I have a physical server. So one more I have a physical server. Okay. So I don't want to use this connectivity. I want to have, let me put it here. These are the VMs. Okay. So these are the two VMs, three VMs. Okay. So now I will put containers here. I will change the color here. Container 2, container 3, okay, container 1, container 2, container 3, container 4, container 1, container 2, container 3, container 4, container 5. Okay. So these are running on a different physical server. Let's say I will get it. This is on a different physical server. Okay. Let's say this is a user. This is a physical server. One more server. This is how it is connected. Let's say these are all the VMs that are running on a particular hypervisor. So either this is ESXi or Hyper-V, or you can put it as virtual box. Something like that you are running all these VMs. Okay. So I want to communicate this container here, this container here, so this container here. I want to communicate. So the native networking does not support. Okay, virtual box will not have this type of connectivity. At container level, it will not give you connectivity, but it will give you from the VM part. Okay, you take the networking from here. Okay, so I will give you connectivity like this. Okay, through VM you are going to connect. So now I want the connectivity like this. So you are getting my point or not? You are understanding, or is it getting complicated? Hello? Okay. So
Yes, sir. Yes, sir.
now what I am doing, see this part, VMware or this virtualization will not be able to do the communication. Okay. For that reason, what you will be doing, you will be installing Kubernetes. This is where you bring in Kubernetes into picture. Okay. So you manage these all connectivity. Okay. So this container B, so you communicate it with this container D, this one. Okay, from container C you communicate. So you handle all the networking here. Okay, the container part. So I don't have this capability, virtual box or ESX or Hyper-V. So these can manage the VM side here. Okay, if you are at the VM level, they will be managing the connectivity. Okay, so you are not looking at the VM here. So you are doing at the container level. That is where your Kubernetes will come and it will handle. Okay, I will handle all this part. Okay, you don't worry. You leave it to me. I will know all this networking. You just run a service here. I will take care of all this. Okay. Inside this, you are able to communicate. That I know. Okay, inside that. So even inside the host also, you will be able to communicate. So everything you leave it to me, no matter how many computers you put. Let's say, so I am going to put it like dash 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 30 computers I am putting. Okay, this is physical 30. Okay, container I have got it like 800 containers I am getting. Okay, so you manage all the networking here. Okay, so now wait, what we will call, these are the containers 1, 2, 3, 4, 5. So what you will do, see app 1, okay, we will put app 1, 2 containers are required, let's say. So app 2, okay, we want 3 containers, 1, 2, 3. Okay. So this we will call it as pod. This we will call it as pod 1, this we will call it as pod 2. So collection of containers, one or more than one, we will call this as pod. Okay, small unit. So here you are using one application, you are using the 3 containers. Okay, this all we will call it as one pod. Okay. So now on the physical server, now we will see from the Kubernetes. Let's say you are on the physical server. So now you will be running. Okay, so there is no virtualization, nothing. Okay, so you will be running pods here. Pod 1, pod 2, like that you will be running pod 20. Okay, if this get crashed or if this goes wrong, okay, Kubernetes will know, okay, what is inside this pod, and let's say you have 30 physical servers. Okay, so you have physical 30. Okay, you have pod 798, pod number 799. Okay, so you have lot of these numbers that are running. Let's say you are running here not 800, let me put it like 120 pods you are running. So if this get crashed, you will automatically start it in other physical server. So you will be running it here. Okay. So all this is managed by Kubernetes. That is why you will be using Kubernetes, not your other aspect. Okay. So now you don't want to use the direct physical server. Let's say, so I am not able to use my CPU. What I will do? So on one CPU, on one physical server, I will run 3 VMs. Okay. On one VM, I will be running 3 pods or 5 pods. This is pod 1, pod 2, pod 3, pod 4 and pod 5. Okay. This also I am running. So either you run it on physical server or on a virtual machine. Okay. So Kubernetes will not care where you are running. Okay, you just give me the pods. I will manage everything. Whatever you want to do it, the container part, I will be running that. That is how Kubernetes will be orchestrating all. This is what called as orchestration. Let's say this crashed, then it will automatically bring up on server 3. Okay, so then you have 2 virtual machine. Let's say you have 2 virtual machine. On this pod will be running automatically. That is why we will be using Kubernetes, so that it will orchestrate everything. Okay, if this fails, it will start here. Let's say if this entire gets failed, let's say you are running 20 pods here. So all this it will take and it will run on one physical server. That is what it will be doing. So now, so you will have it here one master. and you will have all your worker nodes where it will be running. Okay. So you have master here, and these are all your worker nodes. So let me okay, I will bring up one more. Let's say this example. Let me give you this example. So either you can use VMware or VirtualBox. So you are not bound to only use VMware only. So someone is using VirtualBox and someone is using the VMware workstation. So the ultimate goal is to run the VMs. Here, if you want to run container, you don't need a Docker. You can use containerd podman. So I will be using podman in RHEL. In Rocky Linux, I will be running this. Docker engine is not supported there. I will be using podman here. Okay. So now you can run any container runtime here. It is not like you are restricted to only use Docker here. Okay. So container runtime can be any container runtime. So once you have that runtime, then you will be running the pods here. Let's say this is one physical server. Let me change the color here. I am changing the color. This is one physical server or virtual machine. Now you are running how many? Let's say you are running 8 pods here. In 8 pods, let me calculate, are almost 15 containers you are running on this one virtual machine. This is your VM. So you are running. Okay. So this once kubelet, you have kubelet. Okay. So whenever you request, so you request something on the worker node or master node, wherever you request it, client request can come at from any location. Okay. Once you request, then the API server will give the command. Okay. Now you go and execute. Okay. So once kubelet receives this command, then it will create that particular pods here. So now I was talking about your networking. Okay. So this is where you will be getting all the networking part. Okay. So you have kube proxy. So this is where you will be getting all the networking part. So you see it here in the containers. This is the different one. Containers, worker node. So in the worker node, you see the components. Kubelet, this is the primary node agent. Okay. So this communicates with the API server on the master node. Okay. So this agent, kubelet, you have it here, agent. This is going to communicate with the master here. Okay. So you give me the command so that I will be able to execute that. So all it will ensure that containers are running in the pods as specified by the master. So how many containers I should be running? I will be doing it with respective to the pods. Okay. So pod 1, you want me to run 2 containers, I will be running that. Okay. So and it will report the status back to the control plane. So to your master node, it will send, okay, so I am running so and so containers, so and so. So if it is not, if something get crashed, then it will come to know, okay, this worker node has gone down. So then it will take the appropriate action here. So you have kube proxy. You will see that what it is, kube proxy. This is network proxy. This will give all the network rules. Okay. So like in the previous example I told, right? So you will be not able to communicate with each other here. Okay. So you see these orange lines here, small orange lines, which are going through this. Okay. So these all communication will be handled by kube proxy here. Okay. I am going to implement the rules here. I will implement everything here with the cluster node, IP node, everything I will be managing here. Okay. So this CNI plugin is, I am going to assign the IP address. Whenever you create any pod here or in the container, I will give this IP addresses. So these IP addresses, you take it and you connect it to the outside world or to the other networking, other pods or other worker nodes, you go and connect. So CNI is, you will be giving this node network implementation. So that will be container network interface. So you will get the networking interface at the container level. Okay. So this will enable assigns the IP addresses to the pod. So you will not be assigning the pod, automatically these IP addresses will be assigned here. Okay. So this will enable pod to pod communication across nodes. So from this node, from this pod, it will communicate to this. From this to this. From here to here, all this communication will happen seamlessly. Okay. So because this CNI plugin will be communicating, you see these dots here. So through this, it will be communicating. Okay. Kubelet will take the commands and it will execute how many pods should be running. CNI, it will be communicating with other worker nodes. Your CNI will be giving all this connectivity. Kube proxy will be communicating to all. These are all the important components. So you see now container runtime, software to run containers. Okay. So we will be using here containerd instead of Docker. You can use Docker also as a container engine. There is no issue here. So mostly we will be using containerd only. Okay, in Kubernetes. So pods with containers, these are all actual where your applications will be running, application workloads. So inside that you will be sitting in the pod here. Let's say you are carrying vegetables in the cart or you are carrying something on the cart in your cart where you will be running this. So run your containerized applications. So that is how you will be running. So this is what you will be doing it here. Okay. So you have container runtime, creates and runs container. So kube proxy, you will be getting all the network rules here. So what I have to do, how I have to create all that. Okay. So this one you will be getting the networking here, the CNI. So that is the connectivity flow. Now we will go back to our main diagram here. Okay. So now you will understand. So the worker nodes, you have a worker nodes here. Either it is a physical machine, physical server or a VM that runs the application workloads here. So you have a kubelet where it is connecting to API server. Okay, which is a role here. Let's say this is your master here and it is going to get the commands. Let's say you want to run 10 pods, it will be creating 10 pods. Okay. So CNI, it will be giving the IP addresses to the pods here. Okay, you take this IP address, everything. Okay. You have here Calcico and Cilium and Flannel. So these are all the IP providers. You can use any of these to give the IP addresses here. Okay. So these are just assigning the IP address. As a DevOps engineer, you should know like this is the connectivity. You don't have to configure all that. So this is all done by the platform engineer. Okay, you should know that this is how it will be running. Okay, here Q proxy, it will be giving the networking here. So if you want to connect outside, so I will go and communicate with outside. I will tell okay what to do, how to do. I will be giving you all the maintain. It will be maintaining the network rules. Okay, this is how you will be addressing that. Okay, so these all the diagrams are similar only. Okay. So this master and this is the connectivity flow. So then we will be using here installation. I will come back to the installation here. There is one more diagram here. This one. So now you see it here, one by one components you see. So core networking, you have node 1 and node 2. So if you want to do any networking, then you will be getting this networking. Pod A is getting the network interface. CNI plugin is giving the address here. Okay, you take the address, you take one more address. Okay, now you want to communicate. Okay, now you go and communicate. Okay, this is where your Calcico will come and it will be connecting these two nodes here. Okay, so you minimize this. Okay, so then you have Q proxy here. So you have pod IP addresses here. Okay, so you have pod Q proxy which will be available on each node. Okay, it will be running all that how it needs to be connected here. Okay. So here CNI, you can use any of this tool. Okay, Flannel, Calcico, Cilium, you can use any of this. Okay. So this is networking part. So I don't want to go in detail because it will take lot of time. So you need to know how it will be configured. Okay, so then I will come back to the installation here, how the installation will happen. One by one. Somewhere connectivity. So we will talk about this one also, how an overview how it will look like. Okay, so first you will be installing one control plane. Okay, where you will have all these roles. Okay, so after that you will be getting this worker node. So you will not be using all these options. So you will not enable. So these are optional. Cube control and cube admin. These it will be optional so that you can control the cluster here. So kubelet is mandatory here. So all these are mandatory for a worker node. So on control plane you don't require kubelet. Okay, you require only API server. Okay, scheduler, scheduler and other services you need. Okay, on the control plane. Something. Okay. This is on the management, okay, or client tool. Okay, this tool, with this tool you will be telling that how many has to run, how it has to run. Installation here. So first you will be preparing the sequence here. I captured the sequence diagram. Okay. So you are preparing the environment variables here first. Okay. So first OS configuration, you will disable swap, and then you will configure the firewall rules, and you load the kernels here, kernel modules, because you will be filtering it out and you will be forwarding that. So once the OS configuration is done, then you are going to install here container D, install Y container D. So you are not installing Docker here, you are installing here container D runtime. Okay. Then you are doing a kubeadmin and kubelet and kube control. These are optional. Okay. So kubeadmin you require it, okay, for managing all that, or you can have a management tools also. Only this is for control plane here. Okay. Target master node only. Master and all worker nodes. Okay. This is only on master. Okay. You will be doing API server, etcd, kube scheduler and control manager. Once you have done all this, it will give you the command here how to join as a horse. So this command will make a horse. Okay, if you run anything, if you run this command, that particular node will become horse. Means it will become worker node. Now we are configuring here controller here, kube control on the master node only. Then we are setting up the networking here. Okay, how they will be connecting. Once this is done, so you see it, we are using Calcico. Calico we are using here. Okay, so install before joining worker nodes. Okay, so once you do this, now you are joining the worker nodes here. So whatever you got this command here, you will be running it on the worker nodes. Once you run this command here, it will come and join as a horse to that master node. So once you add it, then you are going to verify the cluster here. So this is how you are done with the cluster configuration. These are the steps, and you have all the commands here. Okay. So now this is command flow, installation flow. So first you are doing it on the master node. Let's say this is the shared configuration. So right side you have worker node, left side you have master node. So first one you do it on both the nodes. Okay. On the master node you will do it one, then second one kubelet, kube control, and then networking. Okay. So once you do this, then it will generate a hash here, how to join into this network. So once this is done, you will get a command here to join. So you will take this and you will apply it on the worker node. So once you apply, you will see it. This is how you will be verifying it. So this is on the worker node. I separated it so that you get a clear confirmation how to configure it. So now this is earlier also I shared it like, okay. This is how you will be looking at from the captain's crew. Okay. So this guy is a captain's bridge. This guy will be controlling everything here. This is a control plane here. So you have a control plane, API server. So he will be speaking up what to do, how to handle all that, logbook, everything. I hope this I have already explained this. So did I explain this with this logic or not?
Yes, sir.
So you take this
Yes, sir.
example. If you want kitchen example also, I will get that kitchen example. Okay. So now we will go to that. That is how we have done that. Okay. So now coming back to the configuration and commands. So we will see that how that got executed. So this got hung now. So I am not moving anything now. Okay. Now I am getting it. So now I am giving you how exercise 1, exercise 2. Here are all the diagrams gone here. So all that I got it in one place here at one place. Okay. So here you created one basic pod. So once you execute this, you have created a Nginx pod here. Okay. So it is running it here. So Q control run Nginx pod image. You get it the Nginx image, run it on port 80. So you want to check, then you will run these commands here to check whether the pod is running. So it will give you that pod, and then it will give you the wide configuration details. Then it will describe what it is running. Okay. So all that, this is how it was showing you all the options here. Okay. So you have YAML with probes. So it will be fluctuating between 0 and 1. Okay, it will be running. Okay, if the readiness fails, then pod is removed and then it will be restarting it here. So this will keep on restarting. Okay, so this is one exercise. Third exercise is you will be ordering it here. Okay, every 10 seconds it will be keep on executing it here. So initial containers, it will wait for some 10 seconds and then it will start running. Then it will wait 10 seconds and it will start running. Okay. So now you have sidecar. So in one container, in one pod, you will be running two containers here. Okay, which we call it as side container here. So one, it is main app, and this you will be calling it as a sidecar here. So let's say you are running a web server here. So your application and your web server, okay, and you are sharing one storage here. Okay, multi-container pod. So now here you will be experiencing this auto recovery. Whenever something gets deleted, so you want to get restarted here. So this is what we done it, the exercise on the Kubernetes pod, so that you will get the understanding on how these will be running. So everything it will be running on the worker node only. That's all about installation and running the pods.